Now that you have high-quality protein samples to work with, it's time to estimate their protein concentration. Investing time in properly selecting the protein assay that's going to work best for you is very important so that you can accurately perform that protein concentration estimation. Now, we have a lot of information on that topic on the Lambda U course about estimating protein concentration, so please refer to that for more details. But in sum, there are 4 protein estimation assays that you can choose from. The ultraviolet absorption spectroscopy assay is the simplest and cheapest protein assay. It has a wide dynamic range, but it is also the least reliable option. The Bradford assay is fairly simple and cheap and has a wide dynamic range, but it does not work well in the presence of detergents or for the quantification of small proteins. The Lori assay is more laborious and expensive, but it is extremely sensitive despite its narrow dynamic range. This assay is very sensitive to the presence of detergents and other reagents. The BCA assay is simple, albeit a bit expensive. It is very sensitive and has a wide dynamic range, but only small concentrations of reducing agents can be tolerated. When choosing which protein assay to perform, there's going to be 2 main factors that you're going to have to take into consideration. What is the buffer in which your samples are in, and what is the expected concentration of your samples? Remember that for you to be able to accurately estimate the protein concentration of your samples, you must have fresh appropriate standards and perform technical replicates during your protein assay. For you to be able to perform a quantitative Western blot, you must be working within the combined linear range of all of your targets. For Western blotting, the linear range can be determined as the range between the minimum and maximum signal intensity, where changes in that signal intensity directly correlate to the changes in the amount of protein present on the membrane. Ultimately, what that means is that if you're working within the linear range or within the combined linear range of all of your targets, differences that you see in signal intensity in any of your bands actually reflect the differences in the amount of protein that is present on the membrane. Working within the linear range also allows you to calculate how much protein to load on your blot. If you need more information on how to calculate the linear range of your Western blots, please refer to the other Lambda U course on linear range for quantitative Western blotting. Remember that when it comes to Western blotting, more is not always better, meaning that if you try to load too much protein, you may end up getting protein-to-protein interactions instead of just protein-to-membrane interactions after your transfer is complete. The problem with that is that protein-to-protein interactions are weak, and they can be easily disrupted throughout the protocol. That can affect linearity and also increase variability, which is going to make it very hard for you to obtain quantitative data. Now that you know the linear range of your particular Western blot, it's time to determine how much protein you're actually going to load per well. The way you're going to determine that is thinking about what is the outcome that you expect after your different treatments. For example, if I'm working with an overexpression system and I know that my protein concentration is probably going to increase throughout my treatments, I'm going to load the minimum protein concentration within that linear range. If I'm working with a silencing system and I expect my protein expression to go down throughout my treatments and under my different conditions, I'm going to load as much protein as possible within that linear range. Now, if I'm testing a drug that I have no idea how it's going to affect my protein expression, it could lead to overexpression or reduced expression, I'm going to load the protein concentration that's right in the middle of the linear range. Now that you know how much protein you want to load per well, it's time to prepare your dilutions. You're going to want to load not only the same amount of protein per well, but you're going to want that amount of protein to be diluted in the same final volume. Doing that is not only going to allow you to use an internal loading control for normalization down the line, but it's also going to ensure that we have a constant ion content in all of the wells, ensuring that all of your samples are going to run on the same pace, avoiding artifacts such as smiling gels. Now, if we want to have the same volume in every well, that means that my molecular weight marker is probably going to have to be diluted. However, you have to be careful with that step. Each molecular weight marker has different composition and it's going to be compatible with different dilutants. For example, you may not want to dilute it with sample buffer. Perhaps your molecular weight marker is going to prefer to be diluted with TBS. Remember that you should never boil your molecular weight marker unless it's specifically indicated in the data sheet, and that most molecular weight markers are not compatible with reagents such as protease inhibitors and reducing agents. Now, let's talk about how to keep our work environment clean to avoid any source of unwanted background.